So we're now going to continue looking at how to compute limits in practice. And we're now basically going to take a sneak peek at the next chapter where we talk about continuous functions. So here it's enough for us to know that a continuous function is a function whose graph does not make a jump. As we will discuss, this is not an entirely correct view of what a continuous function is, but it's close enough to the truth that it kind of gives us a correct intuition. So if a function like this is continuous, or you could call it smooth, but that's a bit wrong too, because smooth means that he has no spikes. So a continuous function can have spikes. It can be a bit like this. But anyway, so if you have a continuous function, what can you do? Well, the thing you can do is that if you have the f of a sequence here, and then you take the limit of this, then this is the same as if you do f and then the limit of the sequence, like this. And of course here you need to have that all the ANs are in the domain of f, and that the limit, if it exists, of the ANs is also in the domain of f, so that everything here is defined and nice. But the point here is that if f is continuous, so that its graph is nice and doesn't have any jumps, for instance here this graph would have a jump, but if it doesn't, you can always put the limit inside. And of course, basically every function we'll meet in this course has a continuous graph. The logarithm, the square root function, the exponential function, the trigonometric function, the inverse trigonometric functions, polynomials, even the rational functions are continuous because they make their jumps outside of their domains. Now, how to use this? Well, let's put an example here. Let's say that we want to compute the limit as n tends to infinity of the square root of n minus n squared, n plus 2. Now previously we've seen this expression, so the expression inside of here is definitely tending towards 2. So this has the limit 2. But now we have the square root on the outside here. But 2 is in the domain of the square root function, and the ANs here are also all in the domain of the square root function. And even if they were not, we're actually happy enough if they are so for n big enough, usually, because it's the limit we're talking about here. So if something is wrong here for n is equal to 1 or 2 or 3, we don't care, as long as it works starting or from some n. Now, what can we do? Well, since y is equal to square root x here is continuous, the graph basically looks like this, right? Since it's continuous, I can move the limit inside of the function. And here, this will look like that. And now I already know that this has the limit 2. We showed that in a previous film. So I get 2 here. And then I'm done. So this is a very practical little trick.